Okay, so good morning to everyone. I'm Huan currently FYP under Dr. J. Ishimachi Sensei, and my FYP title will be Development of Tribal Tester at High Temperature Environment. So I'll be move on a bit intro. So the friction in wear is a phenomena that normally appear in the mechanical field at high temperature and gaseous environment, especially on the vehicle, engine, aircraft, and some of the heavy machine. So example of the friction and wear at the high temperature and gaseous environment is the mechanism of the piston inside the vehicle engine that at very high temperature and gaseous environment. So the other example is the car brake pad that touching the car wheel of vehicle to decelerate the vehicles. So another engine is turbocharged engine is the most common example of the friction and wear at high temperature environments. Throughout these three examples, we know that it is important to explore the study regarding to the tribological behavior of a material. They undergo the presence of friction and wear at high temperature and gaseous environment while linear reciprocal sliding motion as the piston motion just now. So another example will be this on the aerodynamic friction at high temperature and gaseous environment that occur in the reciprocal sliding motion of the rocket fuel engine piston pump. And it is also one of the example to describe the friction and wear is always happen in the mechanical field. So from my research of study, the friction and wear are being reduced when two surfaces undergo the sliding mechanism at high temperature and gaseous environment due to the formation of the oxide layer on the surface of the material to reduce the direct contact between two surfaces. This surface is called the glaze layer, and this picture is shown from the scanning electron microscope, and this is the cross-section of the stainless steel through the surface glass former at 450 degrees Celsius, and this is the glaze layer, and this will be the surface of the stainless steel zoomed in. Okay, next will be the problem statement. Since the friction and wear at high temperature and environment always present in our daily life in mechanical and tribological field, hence it is important to study regarding to the friction and wear at high temperature and gaseous environment that in reciprocal sliding motion to enhance the system efficiency and performance. However, the support of the information that regarding to the tribological behavior of the material at high temperature and gaseous environment are not being well to be understood. Besides, it is also have limitation on study regarding to the reciprocal sliding motion of the tribal tester, and it is important also to be considered due to some of the vehicle engine like mechanism of piston in the vehicle engine are in the reciprocal sliding motion at high temperature and gaseous environment. So one of the pin on this tribal tester is have developed in the by the company Endompare, and it is also high temperature tribal tester, but it is in multi-direction sliding motion, which is not suitable to be built a virtual condition to test the friction at high temperature and environment. And lastly, there are some of the tribal tester have been developed that can able to operate at high temperature and gaseous environment, as I mentioned just now, but it is too expensive. And the tribal tester are planned to be designed is use the Raspberry Pi to control and use the furnace to fulfill the condition as the high temperature and gaseous environment, which is cheaper compared to others. So for my project, FYP project is separated into two main objectives, which is at the development part and the research part. For the development part is to establish the tribal tester that can able to operate at high temperature and gaseous environment with linear reciprocal sliding motion. But for the research part, is to clarify the phenomena of friction and wear at high temperature and gaseous environment. So for my hypothesis, it is much more focusing on the research study part, which is the coefficient of friction can be reduced when at high temperature and gaseous environment. So after I clarified my hypothesis, I'm going to talk about what is tribal tester. So for the tribal tester is an instrument to measure the tribology quantity such as the friction, wear, and lubrication. As the picture shown below here, is one of the tribal tester in our tripod lab, which is pinned on this tribal tester. And the tribal tester that is planned to develop is in reciprocal sliding motion, and the friction is produced when the pin and slam being slide from each others. And the normal loading force had been applied to here by using the loading mass, and the friction force can be measured by using the sliding motion, and it will be easy to find out the coefficient of friction to fulfill our second objective. So this picture shows that the reciprocal sliding motion of the tribal tester at high temperature and gaseous environment that had been designed by the previous senior. So this will be a zoom in of the tribal tester that had been designed. So we are much more focusing on this tribal tester arm and the fulcrum and the loading mass and balancing mass. So this will be the tribal tester arm, and this will be the sliding motion, the reciprocal sliding motion as shown as the yellow arrow here. And then we are move to the mechanism of the tribal tester, and the mechanism of the force is applied while using the fulcrum transmission. So it is also the lever transmission, and the whole tribal arm should be in stable and balance by using the balancing mass to adjust the balance. So the total net force and torque are zero along to the tribal tester arm, and it is also balanced by the balancing mass. And since the torque and the net force will be zero at here, the tribal tester arm, and the normal loading force will be depends on how much the loading mass we apply, and using the fulcrum transmission method to get the actual loading normal force at the pin here. So it have the trim material that have been selected. So the first one will be mill steel, which is more ductile, machinable, and weldable. It is the most of the percentage of the material that used in the tribal tester. And the second one will be the stainless steel SUS 310. So because of its low thermal conductivity and specific heat capacity, it is to build the block and the lever arm. So the third one is zirconia alumina ceramic. Due to it can stable up to 800 degrees Celsius, and it is act as the thermal insulator in the tribal tester. So the furnace specification, because of we using the furnace to adjust the condition at high temperature and gaseous environment, so the furnace is much more important in our development part. So for the furnace body size, the length will be 390 mm, and width will be 370, and the height will be 520. So the maximum temperature can be withstood by this furnace is 1200, and our experiment temperature have been fixed by the company. IHI company is 800, so it could be considered to be used, and it is also using the AC current supply and it is want to supply up to 240 volts. And the design specification of the tribal tester is in linear reciprocal motion, and the mechanism is designed to be the fulcrum mechanism, fulcrum transmission for the mechanism of the force applied. And by using the rotational speed of the pin on this tribometer, the standard speed linear actuator of the tribal tester is calculated to be the standard speed of linear actuator is 6.2831 mN s negative 1, and the estimated balancing mass is calculated to be 0.6781 kg. So since most of the design is done by the previous senior, but it is still have many part of the design that need to be improved. So one of the reason why the problem is that the mechanism problem of the zirconia, alumina, ceramic is hard and brittle and cannot be able to fabricate easily using the drilling and treating. So it need the extra support to fix the ceramic part in the fixed position. So we are going to design a clamp to clamp on the multiple ceramic arm and the force sensor, and the other clamp is on the linear actuator to clamp the ceramic plane and clamp on the linear actuator. So the other problem is that dimension of certain parts are not well being assembled. And for example, is the table plate and the level arm stand, the drilling hole, the dimension is not that tally, so we need to do the adjustment. And the other one is we don't have the balancing mass support rod, so we need to adjust it to make it more perfect to be used. So the adjustment on the design just now I mentioned that we were doing the clamp to fix the position of the ceramic plate and slab on the linear actuator. So this will be the clamp, will be here, and the next one will be the clamp and the screw to fix the position of the multi-ceramic arm and the force sensor. Due to this part is very heavy, we using the clamp to clamp the arm, multiple ceramic arm and the force sensor together, and also using the specific screw that make to fix the position of the force sensor and the ceramic arm to make it more stable. Because the ceramic is hard and brittle, it cannot be drilling the hole, so we only can use the original hole to make the screw. So the third one is just now I mentioned is rod for holding the balancing mass, and I adjusted in 6 mm for the diameter and 8 mm for the dimension to holding the hole for holding the balancing mass. Because the balancing mass need to balance the whole arm, so I adjust it to be a bigger dimension to withstand the weight. So my current process is that doing the fabrication on adjustment of the tribal tester design, and at the same time doing the hardware assembly of the tribal tester parts. So besides the programming, the combination of the programming and program flow chart of the tribal tester being done, because from the previous senior also done the program, so I just combine all the program, so it make it one complete programs. So this is the product of my current process, and this is the clamp just now I mentioned it, and this also, and the screw modified by the size of the ceramic hole, and this will be the balancing mass support rods. And I'm going to talk about my flowchart of the project. So firstly, it will start to measure on each dimension, as you know, just now I'm facing the problem as the dimension is not tally. So the second part is planning adjustment on the design. And after that, we'll plan to fabricate all the adjustment part. And after that, we will assembly the whole tripod tester. After that, after the assembly part done, we will going to operate the tripod tester and see whether the satisfies the requirement or not. If not, we are going to planning again on the adjustment on design. So if yes, we are going to do the testing. Like the first will be the sliding circle repetition, and then we'll select the sliding speed as we want. And then we will go start the sliding test and record the data. And during in the same time is also do the tribological test to test the friction force, and we can know the friction force by reading the strength amplifier and then calculate the weight loss on the workpiece and see how much of the difference on the mass. So after that, we collecting this data and using the friction force that we get and the normal loading force, and we can calculate the coefficient of friction. This process from the typological test to the calculating the coefficient of friction will be do repeated 3 times to get the actual to get the accuracy and average result, and then we do the analysis. And this is end of the flowchart of process project. So this is the current process Gantt chart. So I'm at the fabrication part, which is here, and I move to my future plan is to finish for all the adjustment fabrication and assembly for whole tribal tester. The second part will be modified the programming part by adding the coding of ADDA converter. And after this, we're trying to run an experiment test and simulation of the tribal tester that have been assembled to get the data analysis. So that's all from me. Thank you.